Hello students, in our previous videos, we learned the standard form of a pair of linear equations is given by a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. The pair of linear equation can be of three types. First, independent consistent pair, second, inconsistent pair, and third, dependent consistent pair. Recall that graph of linear equation is always a straight line. So, the graph of a pair of linear equations will have two straight lines. Students, note that both the lines can either intersect at unique point or both lines will coincide each other, that is, overlap each other in case of consistent pair, while inconsistent pair will have two lines parallel to each other. We know that the coordinates of such point or points, that is, the ordered pair, will be the solution for the pair of linear equations. But we observe that graphical method is long and time consuming. So students, is there any alternative to graphical method for finding out whether a pair is consistent, inconsistent or coincident? Yes, there is very simple way. In this method, we take ratios of respective coefficients of x and y and constants from equations. But before going to this method, note important points. a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. These are standard form of linear equations. Here a1, a2, b1, b2 are coefficients of x and y respectively in both equations, and c1 and c2 are constants. Now let us take three different pairs of linear equations and work out the ratios of their coefficients and ratio of constants and carry out comparative study. Example 1. Here equation 1 is x minus 2y is equal to 1 and equation 2 is x minus y is equal to 3. Now, suppose we take ratio of coefficients of x, that is a1 upon a2, we get 1 upon 1. If we take ratio of coefficients of y, that is b1 upon b2, we get 2 upon 1. And ratios of constants, that is c1 upon c2, we get 1 upon 3. Here, the ratio of coefficients are not equal, and hence the pair is consistent and has unique solution. Thus, when the ratios of coefficients are not equal, then the given pair is consistent and will have unique solution. Now let's see example 2. Here equation 1 is 2x plus 3y is equal to 9 and equation 2 is 4x plus 6y is equal to 18. Here also, let's take the ratio of coefficients of x, that is a1 upon a2, we get 2 upon 4, which is also equal to 1 upon 2. And ratio of coefficients of y, that is b1 upon b2, we get 3 upon 6, which is also equal to 1 upon 2. And when we take ratios of constants, that is c1 upon c2, we get 9 upon 18, which is also equal to 1 upon 2. Here, the ratio of coefficients and constants are equal, and hence the pair is coincident and has infinite solutions. Thus, when the ratios of coefficients and constants are equal, then the given pair is coincident and will have infinite solutions. Now let's take example 3. Here, equation 1 is x plus 2y is equal to 4 and equation 2 is 2x plus 4y is equal to 12. Here also, when we take ratio of coefficients of y, that is a1 upon a2, we get 1 upon 2. And when we take ratio of coefficients of y, that is b1 upon b2, we get 2 upon 4, which is equal to 1 upon 2. And when we take ratio of constants, that is c1 upon c2, we get 4 upon 12, which is equal to 1 upon 3. Here, the ratio of coefficients are equal, but the ratios of constants is not equal to them. and hence the pair is inconsistent and has no solutions. Thus, when the ratios of coefficients are equal, but the ratio of constants is not equal, then the given pair is inconsistent and will have no solutions. From the table above, we can observe that if we represent pair of equation as a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 by the lines on graph, then we find that for intersecting lines, a1 upon a2 is not equal to b1 upon b2. Also, for coincident lines, a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. And for parallel lines, a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. In fact, students, reverse is also true. That is, if ratios are there, we can find out how graph will be. Let us verify this exercise. Example 1. On comparing the ratios, find out whether the lines representing the following pair of linear equations intersect at a point, are parallel or coincident. Question 1. Here equation 1 is y is equal to 2x minus 1 and equation 2 is minus 4x plus 2y is equal to 3. Question 2. In this, equation 1 is x plus y is equal to 5 and equation 2 is 2x minus y is equal to 4. Question 3. In this, equation 1 is 3x plus 2y is equal to 6 and equation 2 is 6x plus 4y is equal to 8. Let us take first pair of equation. Y is equal to 2x minus 1 and minus 4x plus 2y is equal to minus 3. Write this equation in standard form. We get 2x minus y minus 1 is equal to 0 and minus 4x plus 2y minus 3 is equal to 0. Now, take the ratios of a1 upon a2 and b1 upon b2 and c1 upon c2. We get a1 upon a2 is equal to b1 upon b2 is equal to minus 1 upon 2, while c1 upon c2 is equal to 1 upon 3. Therefore, we find that a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Thus, this pair is inconsistent pair, and as we know that graph of inconsistent pair is two parallel lines. Similarly, students, try second pair of equation. X plus y is equal to 5 and 2x minus y is equal to 4. Write these equations in standard form. We get x plus y minus 5 is equal to 0 and 2x minus y minus 4 is equal to 0. Now, taking the ratios of a1 upon a2 and b1 upon b2 and c1 upon c2, we get a1 upon a2 is equal to 1 upon 2 and b1 upon b2 is equal to minus 1 upon just 1 upon 1, while c1 upon c2 is equal to 5 upon 4. Therefore, we find that a1 upon a2 is not equal to b1 upon b2 is also not equal to c1 upon c2. Thus, this pair is consistent pair, and as we know that a graph of consistent pair is two intersecting lines at a unique point. Students, you can try third example by yourself in same manner. Let's see another example. Find the value of k for which the system of linear equations x plus 2y is equal to 3 and 5x plus ky plus 7 is equal to 0 is inconsistent. Students, here we are given two equations and we are said that they are inconsistent. That is, they have no solution. Therefore, as per our table, the relation between ratios of coefficients of x and y and the ratio of constants is a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Here a1 is equal to 1, b1 is equal to 2, c1 is equal to minus 3 and A2 is equal to 5, B2 is equal to K, and C2 is equal to 7. Now, taking ratios and putting them in our relation, we get 1 upon 5 is equal to 2 upon K is not equal to minus 3 upon 7. Therefore, we can say that 1 upon 5 is equal to 2 upon K. That is, K is equal to 10. Hence, if we replace K with 10 in equation, both pairs will become inconsistent. Students, remember that in questions of such type, always take appropriate relation for given pair of equations. In our next video, we will learn about the next method, that is the substitution method.